Hey guys, welcome to Biddy's Math Binder. Before we start, make sure you take out pencil and paper so you can follow along with me. Today we're going to look at solving equations with rational exponents and radicals. First, we need to talk about what an inverse is, and an inverse refers to the opposite operation. So I want you guys to state the inverse of the following things. So if I ask you what the inverse of addition is, hopefully you guys know that the answer to that is subtraction. So the inverse operation of multiplication would be division. Now if we take a square root, the opposite of taking a square root is squaring something. The inverse of taking any root, not just a square root, but any root, is raising what you've got to whatever that index's power is. So for instance, if you have a square root, that's why we're going to square something. If we have a cube root, then we're going to cube it. We're going to raise it to the third power. If it's a fourth root, then we're going to raise it to the fourth power, and on and on and on. Now, raising a number to a power that is a fraction. So for instance, if it's raised to the 3/4 power, the opposite of that is raising to the reciprocal power. So if I first had to the 3/4 power, to get rid of that 3/4, I would then raise it to the 4/3 power. So we're going to need to know this information to be able to answer some questions. And hopefully when we put some numbers with these examples, this will make a little bit more sense to you. So let's solve some equations. When I look at this equation here, the first thing that we need to do is add 2. Now I want x alone. In order to get rid of that 1/4 on that exponent, I need to do the opposite operation, which was raised to the reciprocal power, 4/1, which is actually just 4. So that 4 is going to make that 1/4 cancel out to where I'm just left with x, and on the other side I get 625 as my answer. Let's look at another example. I want to get x alone, so the first thing I'm going to do is add 6. Next, I'll need to divide by 4 on both sides. At this point, I've got it raised to the 7th power. Now we can do two different things here. We could raise it to the 1/7 power, flip that 7 over. That is absolutely correct. But another way we could do this was take the 7th root. Because whenever you take a root, you can raise it to that number, that index's power. So the 7's on the radical and on the exponent will cancel to be just left with x, and the 7th root of 1 is 1. Let's take a look at another example. I'm going to add 2 on both sides first. In order to get rid of that square root, I need to square. Those will cancel, so I'm just left with a plus 2, and on the other side I've got 196. And last step is to subtract 2. All right, let's do a couple more examples. Let's make one that looks a little bit more intense. A lot of kids tell me they want to distribute the 800 here first, but there's a 7.8 on the power around those parentheses, so I can't just dump that 800 into it. So what I'll actually do is I notice that 800 is being multiplied. The opposite of multiplication is division, so I will divide 800 off of both sides. If you'll notice, instead of writing 7.8, I changed that to a fraction, 39/5, to make solving easier. In order to get rid of that 39/5, I will need to flip it. It will then cancel out. So on the left-hand side, I'm going to type into my calculator 1.8125 raised to the 5/39 power, and then they're going to cancel on the right-hand side. Next, I'll need to subtract 1, and then I will need to multiply by 12. Okay? Let's look at another example. I've got a cube root. To get rid of that cube root, I'll need to cube both sides. They will cancel, to where I'm just left with x minus 2, and then 4 cubed is 64. Add that 2 over. That is my answer. Okay, here, that 3 is being multiplied. I could, in fact, distribute it if I wanted because there is no exponent around those parentheses, but I'm going to go ahead and just get rid of it by dividing. So 207 divided by 3 is 69. I will subtract 5 on both sides. And then I need to get rid of that exponent, so I will need to flip it. They will cancel on the left, and I will type in 64 to the 3 over 2 power in my calculator to get 512. Let's look at another example. Again, the goal is to solve and get x alone. I'm going to add 5. Now I want to get rid of that fourth root, so I'm going to raise everything to the 4th power. They will cancel on the left. 5 to the 4th is 625. Subtract 1 and divide by 3. Next, let's look at another example. I want to get x alone. 222.1 is being multiplied, so I will divide on both sides. I changed that 3.5 to 7 over 2 just so that it's easier for me to solve because I know that I can use the reciprocal power to get rid of it. So 0.639 raised to the 2/7 is 0.456. Now I want to bring something new into the equation. I want us to check for something called extraneous solutions. Anytime that we have radicals in an equation or rational exponents, rational just means basically exponents with fractions. Anytime that happens, we always need to check for extraneous solutions. So what is an extraneous solution? When we solve an equation correctly, but the answer doesn't work when we check it, we call that solution extraneous. Okay, so I know you've always been taught that you can solve an equation and plug it back in and check, and then you know if you're right. Well, on these types of equations, you actually can check and it doesn't work, but you still worked the problem out right. So let me show you an example of what I mean. I want to get a alone. I've got a on both sides of the equation, so let me get that radical by itself by adding the 2. All right, in order to get rid of that radical, I know I can square it. I have to do that to both sides. So on the left, it will cancel. But on the right, I actually have to say a plus 2 times a plus 2. That's going to actually require me to FOIL, multiply all of that out to get a squared plus 4a plus 4 after I combine my like terms. So let's come back over to the other side and let's write what we've got so far. I've got the a plus 2 on the left and then my FOILed out polynomial on the right. This is a quadratic. Anytime you have a quadratic, it needs to be set equal to 0 on one side. So I'm going to go ahead and move that a and that 2 over to the other side. So I'm subtracting that a, subtracting that 2 to get the new polynomial you see there. Well, if you remember from your quadratics unit, you need to factor this. What two numbers multiply to 2 and add to 3? 2 and 1. So I've got a plus 2 and a plus 1. That's factored. In order to solve, I'll need to take each factor and set them equal to 0. Now I can get a alone here by subtracting 2 and subtracting 1. Typically, we would stop here. But what I want you to do is actually take these answers, plug them back into the original equation, and see if they actually worked. So I took -2 and plugged it in everywhere I saw a. And in the end, I got -2 equals -2. That is correct. It does. So I know that -2 is the correct answer. We need to check -1 now. I'm going to plug in -1 everywhere that I see a, and I get -1 equals -1, which is true. It does. So that means both -2 and -1 are answers to this question. Let's look at another example. I want to get x alone, so I'm going to solve. I'll square to get rid of that square root. Next, I will add 2, and then I will divide by 3. I need to check to see if 9 will actually work. So I'm going to plug 9 into that original equation. I get 5 equals -5. That is not correct. That means 9 does not work. There's actually no solution to this equation. See how that works? 9 is called an extraneous solution. Although when we worked it out we got 9, it does not work when we plug it back in. We call that extraneous. It actually is not a correct answer. We have no solution. Let's keep going. I want to get x alone. I've got 2 pieces here, so let me move that x over to the other side first. I want to be able to get rid of that exponent. I can flip and cause it to be a 2. The 1/2 and the 2 will cancel on the left, and I will have a FOIL situation on the right. So I'm going to come to the side. I will FOIL everything out and combine my like terms. Let's go back over here and see what we've got. We've got the 2x plus 7 on the left and my FOILed out polynomial on the right. It's a quadratic again. It needs to be equal to 0. I'm going to minus that 2x and minus that 7 onto the other side so that I have 0 on the left. Now I can factor. I've got to find 2 numbers that multiply to -3 and add to 2. Well, those 2 numbers are 3 and -1. I will separate those, setting them equal to 0, and I will get -3 and +1. Now I need to check both of these solutions and see if any of them are extraneous and they're actually tricking me. I'll plug in the -3, and as you see in my work, I get 4 equals 2. That is not correct. -3 is an extraneous solution. It's not actually working. Let's try 1. I get 2 equals 2. That is correct. 1 is my only solution. Let's look at one more example here. I want to get x alone, so I'll move that 5 over by subtracting. I have to divide by 3 next. And in order to get rid of that 4/3 on the exponent, I will use the reciprocal and get 3/4. They will cancel on the left. 16 raised to the 3/4 power is 8. Now, if you recall, your teachers would have taught you that if you take a square root, for instance, of 25, typically you think, okay, the answer is 5, because 5 times 5 is 25. Well, when you're solving an equation, isn't -5 times -5 also 25? So when you have an equation and you're taking the square root of 25, shouldn't you consider both the positive and the -5? It's really similar in these types of situations. When your denominator on your exponent is even, you have to consider both the positive and the negative answer. So instead of just 8, when my calculator tells me that 16 to the 3/4 power is 8, because that 4 is an even number, I need to consider that plus and that -8. So let's check. I'm first going to just plug in the positive 8 and see if that works. 53 equals 53 is a true statement. The positive 8 does work. If I go through and try to figure out the -8, I end up getting the exact same situation that I just had with the positive 8. I will get 53 equals 53 again. So yes, both the positive and the -8 are solutions to this equation. Let's look at an application problem. The volume of a sphere is 3,054 inches cubed. If the formula volume equals 4/3 pi radius cubed is used to calculate the volume of a sphere, what is the radius of the sphere? Okay, so first I'm going to take a look and go, I know that that is the volume of a sphere's equation. They told me the volume was 3054. So I'm going to go ahead and plug in 3054. I have 4/3 being multiplied right now. We know that the opposite of multiplication is division. However, this is a fraction. You learn in elementary school that you don't divide by fractions, you multiply by the reciprocal. So if I multiply by the reciprocal on both sides, it's going to cancel on the right, and I get 2,290.5 on the left. Next, I need to get rid of that pi, so I'll divide by pi on both sides. And lastly, to get rid of that cubed exponent, I need to take the cube root. Therefore, it will cancel on the right to leave me with r and then 9 inches. So my radius is 9 inches. All right, guys, that's the lesson for today. Be sure to subscribe for more math videos. See you next time.